Hello. Welcome again to Medical Learning Hub. This is another day, another session in mathematics. Yeah, we have this question you're supposed to solve. Actually, not to solve, but rather to prove by induction. Okay, here's the solution. First of all, in proving for induction, it involves a number of steps. One is to show that n equals 1. What will happen if n equals 1? So you test the left hand side, you do the same for the right hand side. Which term do we use on the left hand side? Of course, it's the last term, that is 3n plus 1 t squared. On the right hand side, we take the whole of it. This is n, 6n squared plus 15n plus 11. Okay, so if n equals 1, the left hand side becomes 3 times 1 plus 1 squared. The right hand side becomes a half times 1, 6 times 1 squared plus 15 times 1 plus 11. The left hand side, this is 3 plus 1, 4 squared, this is 16. The right hand side, we have a half times 1, okay, that is 1. Then here, this is 6 plus 15, 21. 21 plus 11, this is 32, which also gives us 16. So as far as the first part of proving is concerned, our statement is true because left hand side equals the right hand side. So what is next now? Now let us, what happens if n this time around equals k? If n equals k, our statement will become, okay, now there's not much to prove on n equals 1, but our task is here that you're supposed now to check for n equals k plus 1. That is the next term after the last term. What is happening on the left hand side? The left hand side will become 4 squared plus 7 squared plus 10, then plus 3k plus 1 squared. Then we add the next term to this one. This is 3k plus 1. Then again plus 1 squared equals the right hand side. The right hand side, this is a half k into bracket. This is 6k squared plus 15k plus 11. Then we add the new term which we have added on the left hand side, which is 3k plus 1 again plus 1 squared. Okay, so the left hand side we get 4 squared plus 7 squared plus 10 squared dot. Then 3k plus 1, this is squared, plus here we shall have 3k, then 3 times 1, that is 3 plus 1 plus 4 squared equals the right hand side, which is a half k into bracket 6k squared plus 15k plus 11, then plus the same term, which is 3k plus 4, then squared. Is there a need of simplifying further from the nature of the expression? If you to expand this here, you get k power 3, and we don't have any k power 3 this time, so we shall just be complicating the issue. So what should we do? Just from here we can prove. Okay, we can prove. So let's say that now our k equals 1. Remember we proved for n equals 1. Then we prove for n equals k. Now, what if this k equals 1? Okay, what do we do here? We take the last two terms of the left-hand side, and we take the right-hand side as it stands. So the last two terms of the left-hand side, the 3k plus 1, this is squared, then plus 3k plus 4, this is squared. Okay, and the right-hand side, we have this long term, which is a half. Okay, let me just put equal sign there. Oh, okay, so we have a half k, then into bracket we have 6k squared plus 15k plus 11, then plus this bracket of 3k plus 4 into bracket squared. Now let's substitute the value of k equals 1. The left hand side we worked out this one, I remember, and we got 16. Okay, not bad. 3 times 1, then times 1 squared, then plus 3 times 1 plus 4 squared is equal to a half times 1 into bracket 6 times 1 squared, then plus 15 times 1 plus